Okay, so the first thing that you need to know when I kind of set this up for you, I went ahead and pre-drew all this just to save time. This is your change in YT, which I call the first meter. This is the platform that it's sitting on, and this skateboarder comes off of. So he comes off at 6.5 meters per second at an angle of 59 degrees. He's going to go, and what this entire question is asking is basically everything in the first half, right? So because at peak, the second half doesn't matter for anything as far as this problem goes. And so at peak, your velocity is going to be y, or your velocity in the y is going to be 0. Okay. So that's important. And your change in y is what we want to solve for first. And then eventually we'll add the 1 meter. Okay. So this is kind of the drawing. This is your total range right here, but they're not asking for that. They actually are only asking for this first part. Okay, so the first thing you want to do is go break down your horizontal and your vertical components. So 6.5 meters per second is your hypotenuse of your triangle. So solve for Vx, which is 3.35 meters per second. Solve for your initial velocity in the y, which is 5.57. You can round these off to 2 significant figures if you prefer. But if you come over here to the y, I set it up as my x and y, because your horizontal, it's constant, right? So there's only one equation that you can use. In your vertical, you got your kinematic equations that you want to go after, okay? So I just kind of list them at the main 3 that you go after, A, B, and C. The one that I chose first to go for time, you don't have to choose time first, but I did, because I knew that I needed to get time over here. And so it's the VFY equals VIY plus G change in T. You might be used to that equation as like A is equal to change in velocity over time, or G is change in velocity over time. My final velocity is 0 at peak, right? Because it's like being like a free fall problem as it like you drop it. Okay, so 0 is equal to 5.57 meters per second minus the G that I'm using is 10.0 meters per second squared, just stated up here. Your teacher might want you to use 9.81, so you'll need to change those. But it's 5.57 minus 10 times time. Solve for that, and you're going to get a time of 0.557 seconds at peak. So this 0.557 seconds, or if you want to round that off probably to 0.6, it is the time for it to go up and reach right here. Okay. Not to come down, not to come all the way down, but just to go up to peak. Okay, for the next part, I chose the equation C, this equation here, which is change in y equals VIY times plus 1/2 GT squared. I plugged in my initial velocity of my y, plugged in my time. This 5 right here is the 1/2 G, so it's 10 divided by 2. Again, make sure if you're going to use 9.1, not 9.81, you're going to need to change that. This is your time squared. Okay, so do the math, and it comes out to be 1.55 meters. The 1.55 is this part only. It does not include the ramp, right? This piece right here, or that it's on. So the 1.55 meters, you need to add the 1. And that's going to get you to 2.6 meters. Okay, so 2.6 meters. So your answer then, if you're looking at your question for B, how high the ground is the highest point that the skateboarder reach. They're saying the highest from the ground, and so that's the extra 1 meter that you need right here, right? So solve for your change in y, just from here to here, and that's going to get you 1.55. Add on the 1, and you're now at 2.55 or 2.6 if you round off. From the B part, I already solved for time, so plug it into your Vx equals change in x over time equation. So 3.35 times the 0.557 seconds, and your change in x comes out to be 1.87 meters. Okay?